Motion matching is state-of-the-art technique in the industry for user-guided interactive motion synthesis thanks to its simplicity, efficiency, and high-quality results. It operates by searching the dataset for nearest neighbors of carefully crafted features. Recent advancements in deep learning demonstrate the great ability in motion synthesis, including situations of diverse motion generation, motion completion, or motion in-betweening that are not possible with motion matching alone, thanks to the prior learned from large datasets. However, these models often produce artifacts such as jittery or oversmoothed motions. Also, these models are generally skeleton-specific and usually tend to fail on large and complex skeletons. The difficulty of motion data acquisition and long offline training time greatly limit their usage. In this work, we present generative motion matching, a generative framework that inherits the training-free nature and the superior quality of motion matching, while enabling a variety of motion synthesis tasks offered by deep learning-based methods using just a few example sequences. Within the time of a single click, our framework generates diverse animations for a complex skeleton. Including the animation of the clothes. When a single clip of locomotion is given as the input example, our framework can also generate high-quality output with a different trajectory. Generative motion matching extracts patches from examples along both skeletal and temporal axes, and progressively refines the generated result using matching and blending, with no need for offline training time. For more details, please refer to the paper. Since our framework explicitly involves the skeletal structure for patch extraction, it can also be used on examples with heterogeneous skeletons and generates a Frankenstein. We demonstrate that our method can be used in various generative tasks, all realized with a unified framework, without the need for training nor a huge dataset. Given the motion of a part of the body, for example, the lower body, our method is able to complete the remaining part with coherent and diverse motion. Our method can also cope with sparse pose guidance distributed along the whole sequence. And when the starting and ending frames are specified to be the same, our method generates an infinite loop. Here, we compare our generated results to classic and state-of-the-art deep learning techniques that can use a single sequence as input. We can see that our method generates high-quality results with sharp details, while other methods tend to generate results with degraded diversity and oversmoothing. Note that our method does not need an offline training stage and runs within a second. Here, we compare the same methods on a character with 433 joints. It can be seen that existing methods struggle to generate plausible results when the skeleton becomes complicated. When multiple examples are given, Ganimator tends to collapse to only part of the examples. In contrast, our method is able to maintain a high coverage because of the explicit enforcement of completeness. We demonstrate the effectiveness of our skeleton-aware component, which enables us to generate diverse motions not only in the temporal but also in the spatial dimensions. Note that the movements of the hands are synchronized in the input example, while a motion that is different from the example is generated. This is not possible without the skeleton-aware component. Our method is both effective and simple to implement. To make it accessible to a wider range of users, we developed a Blender add-on and a web interface, which are easy to use and offer various controls. When the input examples contain widely different content, our method struggles to generate realistic and natural motions via matching and blending distinct motion patches. Thank you for your attention.